Welcome back. This week's video is about converting an LS engine harness over to a standalone harness, and this is pretty much common information for 99 through 2007 truck harnesses. If you're using some of the LS car harnesses, they're going to have some differences. Some of them converted earlier to different computers. The one we're using this week is for a 2006 all-wheel drive Suburban or Yukon Denali, whatever you want to call it. So it has a few features that others don't, but for the most part, they're very, very similar in the process. And I'll try and point out when I hit a difference that you may see if you're using another truck harness. If you're using a car harness, some of this information will be useful, but not all of it. And there are so many out there, it would be very difficult for me to try and hit on all of them in one video. So let's get started. When you come back from the junkyard or from stripping out your vehicle, if you have another vehicle, you're going to have this pile of wires, and your first thought is going to be, what have I done? What have I gotten myself into? So I'm going to walk you through it, walk you through the tools you're going to need, and it's really a pretty simple process. It does take some time if you're going to clean it all up and make it really thinned out, take all the extra plugs and stuff out. But you can make this run without doing that, and I'll try and point out where those points are that you could just stop. So let's get started. To get us started out here, we're looking at the ECM plugs. These are blue and green, obviously, and that's for 2003 through 2007. If you're working on a 99 to 02, those are going to be blue and red. And if you have a choice, your better choice is going to be the 03 to 07, the blue-green. And that's due to compatibility issues with the Tach module for the red-blue ECM when using drive-by-wire. If you're not going to be doing drive-by-wire, if it's going to be drive-by-cable, any of them work well, and you can make the red-blue ECM work with drive-by-wire. It just tends to have more chances of having a compatibility issue with the Tach modules, even if they come out of the same vehicle. I don't know why that is. It's just been something I've run into. So next up, we're going to discuss the tools we're going to have here. You'll see the red folder there on the left. That's got all my LS engine pinouts and transmission information for doing these harnesses. I'll be sharing that on my website very soon, so be looking for that update. Next up is just a small flathead screwdriver, mostly used for prying, but you can also use it to get some of the pins out of the different connectors. 7mm nut driver, I'll show you where that's going to be used pretty quick. We've got a de-pinning tool, and that is, I'll show you a close-up of that, but that is just used to take pins out of the different connectors. Then there's a pair of side cutters, and I actually only show one, but I've got two of these connectors that are pin probes. You push them into the back of the connector or into the front if you can get to it, and that's for using with the multimeter that you see there. We're going to be using that mostly in continuity mode, and there's going to be something pop up here, a card in the top right of the screen to take you to a link to show you how to do that if you don't know. Otherwise, the last two items are masking tape and a Sharpie, and we're going to be using those a lot. In fact, I run out, that whole roll of masking tape gets used up and start into another one. So masking tape works really well. You can use any kind of tape, but the masking tape doesn't leave a lot of sticky all over the wires as you're beginning to take all this stuff apart. Here's a close-up of the de-pinning tool. It's just a really sharp area there that gets down inside the connector so you can move the locking tabs out of the way. Picked up your harness, you probably got the whole fuse block. We won't be using this, but we do need the connector C2 on the back. This is where our 7mm nut driver comes in place in use. Once you're done there, you get that loose. You still have to kind of pry it out. It has two retaining clips on the sides there to keep it in place. Just pop that out and you can set the fuse block aside. We won't be using it anymore. I'm going to do a photo close-up of all of the different connectors so you can identify them. If you didn't take the harness apart, you probably don't know what all of these are for and which ones are which. So we're just going to go through like a photo montage and see them all. And I'll put a little note in there whether you're keeping it or planning to remove it for most instances. And I'll try and cover a little bit of information on each one of them as we go. After this first connector, we're going to go through these pretty quick, so I will try and keep up with the pictures and let you know what they are each for and whether we need them. This is the Tach Module connector or throttle actuator control. This is a keeper, and we're going to be using this for anything that is going to be using drive-by-wire. And all of the stuff I'm going to be doing here in this build is drive-by-wire. This is connector C100, which out of the 11 wires in here, we only need 2 of the wires. One that's going to go to our data link connection, our OBD2 port. The other one's going to go to turn on our check engine light, which is called MIL control, MIL control. All the others, some of them you may want, but you don't have to have if you want to delete them, and we'll go over those here in just a few minutes. Okay, this is connector C152, and there, out of the 10 wires in there, we're going to be using 1 for most people, which is a yellow wire with a black tracer, and it tracks back to the ECM, the green side with pin 49, and that's your vehicle speed sensor. In my case, I'll additionally be keeping 2 more wires in attempt to make the traction control system work in the truck that I'm putting this in. Okay, this is connector C2 off the back of the fuse block, and we're going to be using all but 3 or possibly a 4th wire on this. The 4th wire being the wire that goes all the way down to the starter solenoid to crank the starter over from a key signal. If your chassis already has this in its wiring, you don't need it, or you can use it to tie into so that it's already kind of pre-wired into the engine harness. Interesting little note here is you could cut all the wires off the back of C2, hook all the pink ones to a keyed selection where you turn the key and you get 12 volts anytime the key is in crank or run. Take the 2 orange wires that are on there, hook those directly to the 12 volt positive side of the battery, and then figure out a way to get fuel to the fuel rail, as well as turn the starter over, and the engine will start and run. Absolutely do not recommend that. It's a great way to burn your harness down because there is no protections in that, and you got a lot of stuff going through those pink wires, but that's where all the power comes into the system. This is your transmission park neutral switch, your range switch, Prindle switch, whatever name you want to call it by. And after 2004, it was one big connector like this. Prior to that, as you can see in the picture, it was 2 separate connectors. You only absolutely have to have the ground wire. After that, you can get away with adding or deleting features that you may want. The engine does tend to run better if it knows that when it's in park and neutral versus in gear. So I recommend you use all the features in it. I'm going to use everything in it, including the park neutral features so that it'll do my starter cutout to prevent starting in gear, as well as the reverse lights for turning those on and off when you actually go into reverse. So this switch can handle it all. And interesting enough, if you're using the large connector, you will need to use relays for at least the starter system. But if you are using the 2-pin connector or the 2-plug connector in this switch, then the wire gauge has been heavy enough in my practice that you can use it to run your starter wire through to trigger the solenoid. So that's up to you on that one. This is the second connector on your transmission. All of the wires in this will be used. You don't even have to take the wire covering off if you don't want to recover. Next up is the transfer case wiring on mine. That plug is for the vehicle speed sensor. And if you have a regular 4-wheel drive, you'll have one in the front of the transmission and then one in the transfer case. And 2-wheel drive vehicles will have 2 in the transmission. This is actually the only harness I've ever seen that only has 1, and it's in the transfer case. And I believe that is simply because this truck is all-wheel drive all the time. But that's one of the differences I wanted to point out to you. While you're going through and familiarizing yourself with the harness and labeling everything, check the connectors over real close. I found that I had 4 different connector's broken, and so I'll be buying some new ones. These are the places I found them, and Mauser, EFI connection, but every harness plug is available for the whole system. We're going to speed through a lot of this. I've already removed the wire covering, and anywhere there was a branch in the system, I used masking tape to define it. And then I'm going to show you pictures of each one of the different plugs that I'm removing, and you can identify these all the way back up. I like to start at the farthest point in the harness and work my way backwards up into the C2 and C100, C153, and then the two ECM connectors. And save all your wires, especially anything that comes out of the ECM level, because as you need to add pins for other items, if you want to add a feature or something, you can use those wires with the pins to go back into the ECU and then just solder on an additional length of wire as you get ready. The pins are available online and that kind of place, but you already have what will end up being probably a dozen or more with any length of wire, and most of the time almost any color of wire. You want most things that go in and out of the ECM are in like the 20 gauge range, and that's just because that's all the ECM is really just looking for signal information. It's working pretty much on 5 volts as far as reference voltage in and out, or it's looking at the ground for reference. I'm just going to let you watch me pull wire here, but we've got this on time lapse. And as you pull these out, set them aside, yank them out, you're going to find that it thins out pretty well, fairly quickly. There were a couple wires, like I said, you can choose to leave. One of them was the starter solenoid cable, which is a big heavy-duty purple wire. I left that in my harness so that I'd just be able to tie onto it and it'd already be where I wanted to be at. Here I'm showing you how to remove the covers on the ECMs. There's a little white tab on each end of that blue or the green one if you were looking at it. You just kind of push those in, and then that blue cover, it slides straight up. Those are replaceable. If you had a red-blue system, you could change it over to the 2003 green-blue just by getting the different covers and a new ECM. Then the easiest way I found is to push the wire in just a little bit. You can see it pop up there, and then there's a white tab. Pull that back and then push the terminal towards that tab just a little bit, and that'll release it on both sides. Once you kind of get used to it, you can knock them out of there pretty quick. It's you can use a tool, but I find I can do it just with my fingernail and a little push and pull all at once, and it kind of all comes together real quick and easy. And I was trying to zoom in there so you could see that really close, but it does get a little fuzzy, so I apologize for that. The end ones, the ones on the very ends, are the hardest because you just can't get to them very well. So you can see I was kind of struggling with that one. Here we are, we've already on up to the green one. I tend to leave all the wires just coiled up. I pull them out of the harness, leave them all coiled up at the connector until I'm ready to go ahead and pull them out. And here I'm showing you off a C100, I'm going to be using the cruise control, or I want to make the cruise control work. Well, C100 has 3 of the 4 wires that you need for that. The other wire will be in the back of C2, and so if you choose to have cruise control, you're going to want to save 3 additional wires out of that C100 connector. And if you don't care about cruise control, you can remove those. The 3 in the C100 connector go straight to the Tach Module connector, and so it's easy to find them and figure out which ones you're going to be using. Like I said, I'll be putting up a bunch of paperwork on my website, and then I'll make some links to all of that, try and add some cards and stuff as I'm able to bring information forward. And a lot of this information is just found all over the internet, and I've just collected it for a long time. So with those 3 wires removed from the C100 connector, we'll get the last wire out of the C2, and that'll give us all of our cruise control wiring, and that's kind of there on my closest to me in the picture. what I find is if I do them one wire at a time, I tend to get everything out and I don't have any extras. It does take a little longer. You could easily just go in there and cut all the wires. And so here I'm just showing you that the wires that I took out of that C100 connector really just go right back to the Tach Module connector, which is what we're looking at. It's one of the damaged ones, which is why that housing is missing pieces. And here we are just progressing through, taking out a few more of the wires. I told you earlier we left the starter wire, but there is also an additional wires for the air conditioning compressor. And while I won't be using the original compressor, I'm going to leave it in the factory location, so I may as well just leave those wires in. And when they're up near the top of the harness, up there near the ECM, I can then tie those into my pressure switch or wherever I need them to go to for use in the air conditioning later. So I like to take my time and take these out one at a time. I just trace the wires back, but you could easily use a multimeter to kind of make it a little faster to track where each wire goes to and comes from. And then I like to make notes on all that information in case I have a problem later that I need to track down. As we get this thinned out quite a bit, we'll be ready to start looking for a fuse block, and you could get away with a 4 fuse block and 2 relays, but I prefer to use this at a 7 fuse block minimum, and you're still going to want 2 to 3 relays. Some of that depends on whether you have an automatic transmission or a manual transmission, and some of it just depends on how much you're willing to load a circuit based on the wire size. I like to keep my circuits down to 15 amps or 10 amps where possible, and then the one exception to that would be for your fuel pump, which will be like a 20 amp circuit. Then you're going to need a few relays for the system, at least one for your fuel pump, and then an additional one for the ECM, Tach Module, transmission, O2, mass airflow, coils, and the injectors, and they get power anytime the key is in on, run, or start. I like to split that up into 2 relays just to decrease the load factor for longevity of the relay. And just to show you one more piece, this is a Tach Module, and the wire there that's in my left hand, that goes over to the throttle pedal. And then the Tach Module plug on the main harness is what plugs into this other side. So this interprets the information coming from the throttle pedal and then transfers that information to the ECM for a response. So here we go. We're going to draw out our schematic for the power systems that we're going to need. And the first item there is going to be the ignition switch. It needs to be able to obviously work in off, run, and crank. Next item is the MIL or malfunction indicator light, check engine light. Third item is our DLC data link connector, which is just your OBD2 port. Next item is the ECU, and that's just a generic box. We're not really going to be labeling anything here. And then the final item is we need a 12 volt battery. Negative obviously goes straight to ground on the chassis, the body, whatever. The ECU then has 4 grounds. The data link connector has a ground. The MIL, or check engine light, it kind of works backwards. The ECU provides the ground for the light bulb, and the 12 volt source needs to come from a switched source off of the key. Our ignition switch, as well as the data link connector and the ECU, all need to receive power directly from the hot side of the battery, so the positive post, and those are getting power all the time. So the circuit that feeds those 3 items needs to be fused at 10 amps, and that is going to provide our power to basically control the rest of the system via the ignition switch. So now we're going to add a few more items to our schematic. We've got a row of relays here. First one is what I'm calling main 1. Second one is main 2. Third one will be our fuel pump. And then our 4th and 5th, which will actually be located out under the hood, but we'll draw them in here just for reference. And these are both for fan 1 and fan 2. If you're using a mechanical fan, you won't have those at all. You could use a single fan and only use one of them, but that's simply just to show that the ECU whether originally pinned for it or not, can control up to 2 electric fans via relays. So the ECU has 2 pink wires that come off of it that are for keyed or switched power, and you'll see I've run that line over, and the OBD2 pin DLC connector next to it, as well as the positive side of the MIL light also is connected, and the MIL runs back to the ECU for the ground side, which is what the ECU controls for that check engine light MIL. Now I should have written OR up there on the DLC because I show it both going to hot off that 10 amp wire or coming off the pink wires for the ECU. I usually wire mine into keyed source, but a lot of people do wire them in directly to the 12 volt hot source. So either one is correct, but you will only have one or the other. So it'd be an orange wire going to your battery or a pink wire to your keyed source. Now the next things I've shown is that the fans relays 1 and 2 both get the ground side trigger. That's how those relays are triggered, is off the ground. Those come from the ECU, as well as the fuel pump relay gets a trigger from the ECU, and it again is the ground side of that circuit. And that's why we ran 12 volt positive to each of the relays from the keys. So none of this works unless the key is on. So right now I'm drawing in the circuit that brings power over from the main relay, main number 1 relay, and goes back up and feeds through a second 10 amp fuse. It feeds that MIL indicator, the DLC, and the ECU to power those up with the key on. Third leg off of that relay, as well as the other main relay, are all 12 plus battery, meaning the positive side of the battery, and that they're going to bring battery voltage in. With the fuel pump, you're going to do exactly the same. It's going to go to the battery, and you're going to have a 20 amp fuse in line. And then as 2 optional fuses, you could add what would probably be like a 30 amp fuse. The relays are good up to 40, so you could go that large as long as you run your wire size correctly. But you could run a 30 amp fuse to protect the relay, but we are fusing everything downstream, so that is kind of your choice if you want to protect the relay from that load. And with everything drawn in now, those rows we're going to draw in the rest of our components. The first one there is the transmission. The next one is our mass airflow sensor. Then we have 2 O2 sensors. Next items are going to be our injectors and our coils. Now we have 8 injectors and 8 coils, and I'm dividing them up into odds and evens, or driver side, passenger side. GM calls them bank 1 and bank 2. So if you look at it as odd and even, that would be injectors 1, 3, 5, 7, evens 2, 4, 6, 8. And each of these are fairly high load, but we can run together. We can take the coils and the injectors and tie those together per bank. So we'll have a bank 1 and a bank 2, and we'll take care of the coils and the injectors for each side on that bank. And there I drew that line in the wrong place. It's supposed to come off that other set of coils. So the squiggly line is just my error. Disregard it. Now, each of these, like I said, are fairly high load, so we will want those to be fused. And there you go. We're going to have 15 amp fuses on each of those. And they're going to come back in, and we'll just take those off of main 2 relay. Doesn't matter which one you pick, except for you're trying to spread the load here as much as possible. And we already have a 10 amp load on main relay 1. Therefore, we want to not add 30 more amps to that and be maxing out that relay. So we'll go ahead and put these on relay 2. So the next thing is we'll take the transmission, which has 2 pink wires. Both of those can be ganged back together and run through a 10 amp fuse. And then we've got enough on the mass airflow and both oxygen sensors, we can gang those together and put one 15 amp fuse in line with those. And you can see everything is ganged back straight from main relay 1. It goes up, feeds our MIL, our OBD, and our ECU. Another 10 amp fuse comes off of that and feeds the transmission, and then the 15 amp for the MAF and the 202s. Then the second main relay is basically just taking care of injectors and coils, which is taking up about 30 amps. So we've spread the load fairly well here. We've got 35 amps on one relay and 30 on the other, kind of max planned. If we count up the fuses, we're going to end up with 9. But like I said, 2 of these are basically optional. We could decide not to have the 2 up here on the main relay feeds that are protecting the relays themselves. So all I've done here is gone through and marked whether a circuit was keyed or hot, which would be directly off the battery. And I'm going to delete the 2 fuses that would protect just the relays, or essentially just the relays, since we have everything else downstream fused. So now we're down to 7 fuses, which is what we were talking about before. And then I was just going to show you a little bit more on the 2 fan relays. So like I said, they are triggered on the negative side of the circuit directly from the ECU. The hot side of the circuit needs to come from the battery, and you want them to come only on when there's a key in the ignition and turned on. So you've got hot battery power feeding them, and then keyed switch power to help control them. And then all of that, basically those relays should be pretty close to the fans, or you could have a full relay control circuit, from some third-party aftermarket company. All of that will be under the hood though. And then I tend to use circuit breakers on fans and stuff like that so that they will auto reset if one does happen to pop. You don't have to actually go out and change a fuse to get the fan working again. And then the last thing I'm going to do is go ahead and start showing you a couple fuse block options that you could use to keep this system a true standalone. Additionally, I'll probably talk about the circuit system I'm going to use, which will be to tie the whole truck's chassis, lighting, all that into the ECM and engine harness, so that it's all in one big fuse block, but it's all going to have to be custom built there. So let's get into the next part. So one of these 4-place fuse holders and 2 relays would get the job done on the minimalist side. Then there's this fancier version with plugs, and a little bit fancier version than that plugs in. These both have a lot of adaptability, but they have a lot of parts that you would need, so they get kind of expensive. Then there's a kit like this that uses those 4-place pieces, and you keep ganging them together until you have all you want, and you can do a full vehicle off of those because you now have the ability to have flashers and extra relays, and you just keep adding on until you have all the circuits you need. This particular kit is from Ron Francis Wiring, and it's called their Retro Series. And then there's this system from Bussmann. I'm going to use a larger one than this even, but this is kind of my planned take on it. I'll be able to add up to 22 or 23 fuses plus all the relays I need to make a very compact and complete system in one place that includes everything for the lighting and the radio and air conditioning and the whole bit. So all of that will come into that one box. But for us, we're doing a standalone, so we're going to use a different system entirely, and let me show you which fuse block we're going to use for that. So these are the 2 systems I've had on the shelf out in my shop, and I've used both of these types of systems before. This first one is small and compact, comes complete with all your connectors, your fuses, and 5 relays. The relays mount to the outside of this little bus. This gives you an option for, I believe, 10 fuses, and 3 relays easily mount, or all 5 relays easily mount to the outside. And then I'll kind of show you how all that would look. So there you have it. That would be a fairly compact system. You'd get all your relays on the outside, have a cover for the fuses, and you, working off the back, you get to decide what gets ganged with what as far as power supply and sources. And then these relays, I think, were rated at like 100 amps, which the plastic in this system would never handle 5 of those things drawing 100 amps through it, but that's not really the important part. We'd never be looking at more than 35 amps to 40 amps anyway. So that's this system, and then we'll pull out the other one that I've got. Now, the second one is a little larger in form factor, but everything fits inside and underneath the one cover. Again, comes with all the different connector pins. Actually, and this one actually comes with some 1 page of instructions, but take the top off, and then you can see where you can put 5 regular relays as well as 1 smaller relay, and then I fight with getting the bottom off, which I guess is good because it means it's not going to be falling off all the time. So with this apart, you can now see the bottom side. We have area to plug in all of our relay and our fuses. Now this one only holds, I believe, 6 fuses, and like I said, 6 relays, 5 of them the normal form factor, and then one of them smaller, not the micro, but I believe the mini form factor. And so this one's not going to really be good for our current standalone system, but it would work, especially if you were running a manual transmission or didn't have the fans or something else where you just needed 6 fuses where you could just drop down on your circuitry essentially. And I was kind of showing you the prices there. Both of these are fairly inexpensive. I think one of them was $19 and one of them was like $12. So one downside to both of these is they are not watertight. And I was just showing you there that 6th relay location is not the standard size relay. It's a different size, and it doesn't really matter. We're not going to be using this one, but any of these would work well if you're willing to adapt a little bit. So I'm going to put this one away, and we're going to get out the first one I showed you, and that's the one we'll be using for our standalone system. Now this is just to demonstrate how you would hook up a standalone harness. And like I said, I'll be using a different form factor completely, and I want mine watertight because I'm planning to probably mount mine out under the hood or up under the battery somewhere. So this is the diagram that I'm using to build the harness, and just as an update, I found 2 errors in it, and I'll be sharing those with you shortly, just to walk you through the diagram, and then we'll cover the errors in a minute. First we have our battery, 12 volt, and then we got our ground side coming off, and then the positive side running through 6-gauge wire, and I would run it as red. It comes down, it feeds our first 2 circuits. One's 10 amp, the other is a spare. Then it comes down and feeds main relay 1 and main relay 2. Additionally, it feeds the fuel pump relay, and from there we'll have control of the fuel pump. The ground side is a 14-gauge black wire, and that's really overkill. It could be 18 gauge even. So then the ground goes over and feeds pin 85 off of our 2 main relays. Just for reference, pin 85 and 86 are interchangeable, it doesn't matter. Our battery feed goes through that 10 amp fuse, feeds 2 hot wires for the ECM, they're both orange, then goes back and feeds our ignition switch, which is really just a toggle switch on this particular harness. And that, when the toggle switch is flipped on, it feeds pin 86 in this case on 2 of our relays. This is one of the errors right there. That pin 86 on the fuel pump relay should go to ground actually, or because the ECU controls the positive side. Now our main relay, we've got another spare, which another error because we need a Tach Module fuse, so that'll be used there. And then we've got a 10 amp feeding our MIL, our DLC, and our 2 pins for the ECU. It also feeds 2 pink wires for the transmission and a 15 amp to the mass airflow and 2 oxygen sensors. Main relay 2 then feeds bank 1, and that's the injectors and the coils, and bank 2 injectors and coils through 2 15 amp fuses, and leaves us another spare. And that pretty evenly splits the loads between the 2 main fuses or main relays. Additionally, we have the fuel pump relay going through a 20 amp fuse. It's a 14 gauge wire. I like gray. That's just what the factory has used. And then this is one of the other errors. That ECU control is actually 12 positive volts, so 12 plus volts, instead of the 12 negative the way I have it drawn. So I'll show you that correction. So after looking over my video, I realized I made a couple errors, and I ended up correcting them even in my harness when I went back to check it. I left off the Tach module completely, so that is also going to be coming off of our main relay number 1 with a 10 amp fuse. which would have been one of the spares, and we'll just use that for the Tach module. Okay, so for some reason I was thinking like the fans, the ECU controls the ground side, the 12 volt negative side of the relay, and I drew the fuel pump relay the same way, and in fact it's just the opposite. On this model, the ECM controls the 12 positive side of the fuel pump relay, and you just ground out the other side. So you can see there the correction, and I don't know, I think I wrote 8 gauge wire there for some reason, but 14 gauge is plenty to go to the fuel pump. If you really want to step it up, go to 10 gauge if you're going to be running a high volume pump or something. Anyway, so there were my errors. Tach module, we just needed an extra fuse. You could probably run that tied in with the ECU or the transmission, but we had plenty of space, so we'll just run that separate. Additionally, one thing that I want to note that you may not normally see is this particular harness is going in like a dune buggy, rock crawler, complete off-road vehicle, where it really doesn't have a key. What it has is a toggle switch to bring power on, and then a push button to run the starter. So we're bringing power off of the battery through a fuse to the ignition switch, and then the ignition switch, which is just a toggle switch, gets turned on and controls all the relays. So you'll see on the other schematic, we also have that circuit. So I'm going to draw a couple of schematics, but I wanted to give you the corrections on that one. This is that same schematic drawn out in a way that references the fuse panel, the relays, the battery. Just kind of puts it a little closer to what you're going to be doing. And again, you can see here we've got power coming out to the ECU and to the ignition switch, and that's just a 10 amp battery circuit, so it's hot all the time. It goes through the ignition switch, which in our case is a toggle switch, back out, and you know, it only need, I think I have 16 gauge there because I'm splitting it so many times, but you only need 18 gauge on this side of the switch to run down and feed your 2 relays, since the third one, which is why that's scribbled out, the fuel pump relay is controlled on the positive side with the ECU. After 2008, the ECUs, I believe, control the ground side, and I think that's just what I had in my head. So anyway, the other thing is here you can see we used the spare fuse to run the Tach module. So that's it. Just wanted to share all that with you so that it's accurate. I will be putting these schematics with the corrections up. And then additionally, I have one more schematic, looks very much like the others. And the only difference here is we don't have the whole ignition switch deal. You will need to bring in power from an ignition switch, but assuming you're driving a regular vehicle that has a chassis harness, all you'll do is tap off of your ignition switch with a run and crank signal. So you need 12 volts during cranking and during run. So it can't be hooked to the one that does the starter solenoid, and it can't be one that's just the accessory. It's got to be the run and crank. And that will power up all the relays. Well, power up the 2 main relays, and then when the ECU has power and is ready, it'll power up the fuel pump relay. But and then we've got all the things corrected, and I kind of colored them in so you get some idea of what the, and I try to use the GM colors. So red is battery hot, orange is ignition hot, pink is also ignition hot, after the key or after the switch kind of thing. So anyway, I hope that helps, and we'll get on to the rest of the video. Okay, so now we're going to be wiring up the whole fuse panel. We've got a 10 fuse panel, we've got some external relays, and I've got some 6 gauge and 8 gauge wire. I also went through my box, and for example, this is a set of wire that's twisted pair, so we can use that for the data link connection or some of the other sensors if we need to extend them. Every bit of wire that I have here actually came out of a box that I have of just scrap wire, if you will. Some of it's brand new wire that just hasn't been used, but it was stuck into a box with the rest of the scrap wire. I've got a lot of black wire, and some of it says ground, and some heavy gauge black wire. But we're going to go ahead and build this, and the nice thing is I really didn't have to take out any new wire. So, and this is kind of gonna, we're mixing and matching here because this harness is the one that we've drawn. It's kind of for the dune buggy slash rock crawler, whatever off-road vehicle that doesn't really have a key. But we've also been working on the harness for the 2020 C20, and so it's a little more complicated, but they will work together if we join them. So right now I'm showing you that I got my 6-gauge wire, and that wire is red. We're going to be running that as our main feed from the battery. And then I've got additionally some 10-gauge and 14-gauge wire for running additional circuits. So this fuse block allows you to have the relays clip onto the side, and we need 3 relays, so it conveniently allows actually for as many as you want to stack, because they are kind of dovetail together and slide in together. Although one of them is missing a piece, and you can see right there the corner is missing, so it won't clip on. So that one's no good, it goes in the trash, but it still leaves us 3 that came with the kit, and we can get all of our relays in place. We'll be looking at is probably needing to identify these in time. We're going to have a main relay 1, a main relay 2, the fuel pump relay, and then we'll try and just kind of tie them in to where they line up pretty well with the different fuses that we'll be using. So then the kit comes with all the necessary pins we'll need to plug in, and they're basically bus barred together. So we'll just clip off what we need for each different circuit. For example, we need 2 for the first one, and 4 for the second, and 3 for the third, and then 1 more pin for just the fuel pump relay. So we'll get these cut up where we need them. With all this cut up, now we can add the rest of our pins. So we've got the ones, the gold bag there, or the bag with the gold pins, or those are for the relay itself. And we'll have to basically get everything laid out to where we can bring all our power in. So then we need to look at the relays, and we've got a couple different pins here. 30 is this pin that's sideways, and then 87, which is the pin where it goes, and then the 2 top and bottom are 85 and 86. Like I said, they're interchangeable. Whenever the relay is turned on, 30 connects to 87, and the middle pin there that I was pointing out is 87A. So when the relay is off, the power transfer goes between 30 and 87A. For none of these 3 will we be using 87A. But we do need to get power to 30, and we want to get that power off of that main 6-gauge wire. So what we're going to do is essentially split that down into smaller 8-gauge wires, and then that way we have good power to the relays that can be transferred on to the rest of the circuits. So we've got a couple crimper tools here that we'll be using to crimp everything in, and we've got some wire strippers to strip off the wire. I'm going to go ahead and speed through a lot of this so that you can just see it happen. I like to add a little bit of heat shrink to the wires just to protect the different terminals. I try and match the color, but that's not always possible. Once that's heated and shrunk down, then it's a matter of just starting to kind of lay out the wire in the direction that you would want it to go, and kind of have a plan. You know, are your inputs and outputs, if you will, are all going to go out the same side? Are they going to come in one side and go out the other? You just kind of have to lay it out based on what you think is going to work best for your vehicle. Okay, so now we'll need to start adding the rest of our wires. We've got things kind of laid out how we want them. We can cut it off short, crimp on the next connector. We're going to do this 3 times for each of the relays, and that'll be our pin 30 on each of the relays, which is the input to the relay. And once that's done, we can go ahead and get things set up to tie those into our 6-gauge wire that'll be running straight to the battery. And got a little piece of heat shrink on there, get these stripped off, kind of hook them together, and then we'll tin those up, which means just add a little bit of solder. They'll hold themselves together then. And my soldering iron here, this is a 25-watt soldering iron. It's really not big enough for when you're working with this heavy gauge wire. So here we got the main feed, getting it tinned up. Here, whenever you're working with this heavy gauge wire, I like to use a mechanical connector. So much like a butt connector, this allows you to overlap the wires, and then you crimp that on, and then go back with a soldering iron and some solder and heat that up and let the solder go in. Like I said, I really have too small a soldering iron for this project. Really should have a 60-watt soldering iron or something bigger even. Anyway, so I'm going to go ahead and clip here, and we'll come back. Basically, all we're going to do is finish the soldering and then put some heat shrink on it. Well, unfortunately, I didn't have any red heat shrink that was large enough to go over that, so we'll use a piece of green and then get the wires coiled up and out of the way, and that'll finish that off. Next up, we've got to start working on the pin 87, which is where the power goes through when the relay is actually turned on. And for those of you that aren't aware, a relay is just a mechanical switch that is remotely controlled. So we're getting out those little gold clips and the singles that we've cut up to put in pin 87, and then we'll start hooking those up to the different fuses. So now these first two fuse slots are going to be 10 gauge wire, and they're coming off of the relay, and then they'll daisy chain together. And now we've got the second relay, that's main relay 2, and then finally the third relay, which is the fuel pump relay. And again, all these wires are 10 gauge. My first kind of bus bar, this is the battery feed for the first two fuses, what would be fuse 1 and 2, or the top two in the drawing, and those are going to be added directly to that battery feed. So I probably should have put those under that green piece of heat shrink when I was doing the others, but no big deal. I'll just move down the wire just a little bit, strip it back, and then just join that in. I don't even have to cut the 6 gauge wire this time. I'll just hook it in just upstream of that other, so it'll work. And now this these 3 wires that I was clipping back there, those will be hooked to the next couple bus bars. The first one being a 4 connector. So we'll get it all set up and get it crimped on. So I didn't leave myself quite enough room on the length of that wire, so I kind of had to just take the relay holder back off, and then I could get everything lined up and pushed down into the sockets for the fuses, and that's just those connectors at one side of the fuse. They were a little tough to push in there. Everything's kind of stiff, and I don't know, I guess the clearances are pretty good for that reason, or maybe they're not good at all for that reason, whatever. I did learn a couple little tricks. If you take some of the extra tabs off, that makes it easier to crimp them up, and they weren't doing anything except for being in place of where you would have any other buses or bus ties together. And what I mean by bus ties is if you're ganging multiple fuses together, you can leave those things connected to each other, and they are bussed or ganged into multiple fuse positions in. So now here you go. You can see me. I've got some wire insulation stripped back, and we're going to go ahead and solder on that fuse 1 and 2 lead, power lead. So now we're starting the pin 85 in our diagram on the relays, that side of the circuit, and that's what's going to bring power into each of these relays for the control side. So with this power being ignition controlled, and or on the fuel pump side being ECM controlled, and then we put a ground to the other side of the relay, pin 86, we then have a circuit that we can control that relay. So here we are. You can see those are daisy chained together, and I'm just labeling my wires. You could use a fancier label system, you know, something else, but what you'll learn is you're going to be tearing them off anyway. So now I'm going to be daisy chaining in the ground signal, and that's what the black wire is for. And those are going to the, like I said, pin 86, and then the coiled up green and with a white tracer wire there, that'll be what controls the fuel pump via the ECM, and that's just the GM color for that particular deal. So, and I happen to have some of that wire, so we'll go ahead and get these all set up and then move on to the fuses. Okay, so we skipped ahead here. We've got the grounds already done, and you'll see the green wire with white tracer is complete and in the socket for the relay control. And now I'm doing the gray wire that's coming off the first or the last fuse, the 20 amp fuse, and that's going out, and that would just go directly to our fuel pump. And I'm kind of working my way up the list there, so all of the connectors at this point all have to get singled up and get any extra material off of them. And these are for the fuses, and then we'll add each one of the wires, and you can see the yellow heat shrink there. We'll add that just to protect those. Okay, so now you see me messing with this 16 gauge orange wire. That's going to be for our fuse 1, which is the ECM, and on this harness, the ignition power that controls everything. So this is your hot side power, and we've got 2 wires in there, so we just want to make sure they're both kind of soldered together as well as to that connector, since they could get some stress and stuff. And then we'll label those, and each one's labeled separately. Well, like I said, one to the ignition switch for the buggy idea, and then the other one goes to the ECM. And you'll see they kind of come out 2 different directions because of the way my system will work. So that green wire and the orange wire now are going to the ECM, so they're coming out one side. So now we're working with this 16 gauge pink wire, which will let us handle all the rest of the circuits except our ignition and coils, where we're going to want a little heavier wire. We'll be looking for some 14 gauge wire for those. So the first connector we're putting on here has 3 wires off of it, and they control the check engine light or the mill, the data link connector, which is the OBD2 connector, and 2 to the ECU for ignition power. So again, just solder those on, put on a little heat shrink, heat that up, which is what I'm doing off screen there, and then it gets plugged into the next port, and that'll be for that fuse. And then the really sharp ones here, you'll notice I did these out of order. I've got 3 wires there connected together, and that was going to be for the next fuse, which is the mass airflow and 2 oxygen sensors. So that's why that has 3 wires instead of what we need for the transmission. Beginning to see the process. You just take each one in turn, label your wires as you go. So I'm going to go ahead and skip ahead to where we're a little closer towards the end of this process, since the rest of it is just over and over the same things again. Okay, so we got through all that, bundled up the wires for both sides. Now I'm just adding some tape here for some temporary labels, and then I'll make some nicer ones with my printer that will be easier to read and last longer. Then we can add our fuses and our relays. We can get those all plugged in. And there's a slot, 3 slots on the sides for a couple extra fuses. Put the cover on. So now we have a very nice finished product that we can tie into the rest of our harness or send on to our customer in this case. So now I'm back to working on the main harness, and what I'm doing is starting to group all the wires together because I'm moving most of the components that this wiring harness feeds. So the ECM will be in a different location, and I'm going to be rerouting the harness in different directions because of where I'm putting some of the components. So I've already been out to the shop once, maybe twice, to lay the harness over the engine and just kind of begin figuring out where I want stuff. And so we'll be going back out there again multiple times to figure out where everything goes. So here I'm beginning to lengthen a lot of the wires, and as I complete a section, I go ahead and usually try and loom it up. And most of the stuff needed about 10 inches of wire. Few areas needed as much as 30 inches, but most of them were just 10 inches. And basically all I've done is flip the harness over and reroute it. Some of the wires you're going to have are going to be what's called a twisted pair. In this case, I needed about 18 more inches to extend the vehicle speed sensor, the VSS, at the transfer case. And you can duplicate that with just putting one end in a vise and then the other end in a drill. And it doesn't need to spin real fast. You just spin that until you get a similar tightness or number of twists per inch. Go a little extra and it'll, because once you release it, it's going to try and kind of curve up a little bit. Anyway, that's how you do that. And it is important because the 2 wires are basically, by being twisted pair, they're shielding the signal that's in them from other sources of electricity or interference. So you do, if you're duplicating a twisted pair, you do want to make sure you put a twisted pair in there to duplicate that. Okay, for reference, this is about the 3rd or 4th time I've been out here to kind of simulate where the wiring harness is going to go. And I've pretty much got it narrowed down now to my final fit, and so I can, last couple wires that I still needed to check into, I can do that now. So in the truck that this is going in, the battery sits right in this area. So I'm going to put the ECM computer underneath the battery or alongside the battery or something. So I've left myself plenty of room there to be able to figure that out. So these are all the wires that go to the different switches and fuse block, and those will be getting connected. And then it's going to run up along the frame, pretty much in the place that one of the original chassis harnesses ran. So basically going to be able to reuse some of their connections. I've split off the injectors, the coils, the sensors, the throttle body, everything that's on the top of the engine right here by the air conditioner, compressor, and the water pump. And they're going to run up to the top of the valve cover, and then I already have this one. I'd already got pretty much nailed it down last time. Now one of the things you're going to notice is I have 8, 6, 4, 2 in the back, and that's because this harness used to come in from the back of the engine. So we're on the ECM, we will repin the ECM for this to be number 2, this to be number 4, and so on, and we can just do that at the ECM, and we don't have to change the pink wires, it's just the signal wire. Then I've shortened up the throttle body wires, so they'll go in here to a plug, and I've got a new plug coming for that. That was one of the ones that was broken. My mass airflow wires, the connector and everything are good. The problem is I don't know where I'm going to put this yet, so I'm just going to leave the full length, and we'll adapt that later. And I've got some wires that go in underneath the intake manifold down here, like this one with the blue connector that connects to the NOx sensors. So at the back of the engine we have the cam sensor and an oil pressure sensor, which we'll be taking this one out and replacing it with one for the gauges in the vehicle. And then we have a couple places that grounds were originally hooked to. So
The rest of those wires are going to come in underneath the intake manifold and plug into all that, so I extended those. So coming in from underneath the intake manifold is the map sensor plug, so it'll just come up the back and plug in. This is the Egr Purge Valve for those of you who are unfamiliar, and so this is one that we deleted, and they make aluminum block offs for this, so we'll just order one of those for $8 or $10 and replace this, get rid of this whole system up here. Driver's side, and the wires for the coil and the injectors for this side, as well as we've got a plug for our alternator. And unfortunately, I think I made it about 3 inches too short, so it did the same thing for the water temperature sensor. I made those wires about 3 inches too short, so I'll be redoing those and extending them correctly. And then on the coil, I'm a little long on the wires, but that can all be, by the time it gets tucked in and put away, I don't think that's going to be a problem. And then I had not hooked up the injectors. I had not soldered in the injectors on this side yet. And you can see, so the amount of overlap that I've got there is because this is where it fits really well into the injector harness. So I'll be cutting those wires back and shortening them, and then I can base the rest of the injectors off of that length. Okay, and then we come down the passenger side of the frame again. Down, we'll reuse those clips, and this will tie into the bottom of the body so that we're up above the exhaust. And the transmission connector was plenty long. Anything we could have taken a little bit out. I had to extend the vehicle speed sensor wire. It goes all the way back to the transfer case. And then we'll reuse this this wire capture. The wires for the range switch and the O2 sensor on the driver's side have all been extended, and all will get captured there. So now I have a completed length harness, except for the injectors on the driver's side, and that'll be corrected soon. And the only thing I forgot to add is you can remove this plug right here on the passenger side, and you can add another water temperature sensor for your gauges. So I'm going to be adding a wire to the harness. Probably add it to this harness, which feeds the crank sensor and the starter, and they go in behind the intake manifold right there with the rest of the wires and kind of come in like this. So then I can just come straight up with it right next to the spark plug there. So that's the only wire I forgot to add, and I'll go back and get that in. We'll start looming all this up to make it look pretty. And then finally we'll leave that area at the front mostly like it is until I get my new fuse block and everything that's going to be used for this particular harness.
Let me just say I'm really impressed if any of you have stayed into the video this long. There's just a lot of information here, and I could not see where to break it up to make it into 4 or 5 parts and give any real value in any one piece. So here it is. You see me adding and lengthening the last few wires and then starting to do all my loom. As I get close here, you know, I ran out of the 1/4 inch looms. There's a couple wires that are going to have to come back to. And then what I'm doing here is splitting out the different sections that are going to be going to either the fuse block or into the cabin of the truck. And like I said earlier when I was drawing the other out, basically I just need to get my new fuse block, and then I'm writing down a list of all the different wires that need to go where for this. So on this system, we have a ground that goes to battery, main power line that goes to battery, and then the orange and pink wire go to the toggle switch that turns the power on. And they'll have a similar purple wire coming in that goes straight to their starter, and that'll be on the push button. And that's it. The engine will start from there because it has power and ECM control. So I would show you hooking all this together, but 2 different vehicles. I just happen to be building systems at the same time. So. Okay, well, let me just say thank you for sticking with it this long. I know this information is kind of dry, and I'm trying to show you so much about it. I don't know if anybody's going to make it to the end here, but I hope you do. I hope this is helpful for you. Again, thanks for joining. Thanks for watching. And we'll see you again real soon on Allison Customs Project Car TV.